Hello children, so we are back with type 5 questions of circle theorems. In this type of questions, I have included questions which have all the theorems included. So typically exam type questions where not one theorem or two theorems, you will have to use multiple theorems to answer your questions. So you have to remember all the 8 theorems of circle. So to answer these kind of questions, okay, let's begin with the question number 1. This session will be a little longer because it is exam type questions. I have included little more number of questions, okay, but you can always pause the video and write. So very simple question. The points ABC lie on a circle. ABC, they are on circle. ACB is 54, AB is 14 centimeters. Calculate radius of circle. How to do this? Now they are asking us OA or OB. Till now it was only angles, now they are asking side. How to do? So if this is 54, if I draw this line, this will be 54 and this will be 54. I will zoom it for you so that you can see clearly. Now why it is 54, 54? Let me explain to you. AB is creating an angle 54 at the segment. AB is creating some angle at the center, so it will be double of 54. So this whole thing is 108, but I divide it in two parts. So this is 54, this is also 54. This is 14. A line perpendicular to the chord divides the chord into equal parts. So this has to be 7, this has to be 7. Now, yes, you are getting it right. Now you have to use trigonometry to find the radius. This is radius. You have opposite side and you have hypotenuse. Cos of 54 equals to, opposite means sine. Sine of 54 equals to 7 upon r. Therefore, r equals to 7 upon sine 54. And this will give you your radius. Let's calculate it is 7 divided by sine 54, 8.65. How much is the radius? 8.65 centimeters. So here, not only we did the circle theorems, we also used little bit of trigonometry. Okay, so you have to be abreast with trigonometric ratios, and here we are using opposite side and hypotenuse. The ratio was sine, and we didn't know what was the radius, so 7 upon r, because r was the radius of the triangle, because this is a 90-degree triangle, right? And here what circle theorems we used, this line is dividing the chord into equal parts 7, 7, and the angle was double at the center, what it makes with the segment. Okay, I hope you understood this one. Okay, now let's do next question. Here, ET, BT are tangents to the circle. Center OP is a point on circumference. Okay, this one. Angle X. Okay. See, this is a tangent, this is also a tangent. So this also has to be 54. Why? Because isosceles triangle. Two tangents are equal, so adjacent angles are equal. 54, 54. Then how much will be this angle? 72. Then how much will be this angle? 108. Y is how much? 108. I told you the trick, right? If you divide it and make it two triangles, you can easily find the triangle. If this is 108 and if this is 108, this is how much? 72. All angles done. What is X? 72. What is Y? 108. And what is Z? That is also 72. Understood, right? We have done this kind of questions in our previous types. Let's come to this one. This is the image which was there on the home screen of this video. Okay, TPK is a tangent. Okay, this one, this long line is a tangent. TSQ is a straight line. TSQ is a straight line. Okay, agreed. They have given PQ is equal to QR. Okay, those things. PQ equals to QR, that is also given. STP is 32. We need PQR and QRS. PQR, this angle, and QRS. These two angles are the task to be found, marked angles. Okay, let's begin. So I'll zoom this figure and bring it to the center. You're able to see, right? Now let's begin. Go to alternate segment theorem. Okay, this is 58, right? First we will do this big triangle. How much is this big triangle? Okay, first we will use alternate segment theorem. 58, so this angle inside, I'll use another color. This one will be 58. I've used alternate segment theorem. Now see RQP, this triangle, RQP triangle, isosceles triangle, these two sides are equal. So this angle also has to be 58. Now can you find RQP? 180 minus 58 and 58, 64. So first task is done, 64. Okay, and half of this also we know. We only need to find this particular small thing. If you are able to find out this, our job will be done. Okay, now to do this, what you will do, look at this triangle. Which one? This TQP. TQP. You remember, this is external angle of a triangle. This angle, or this triangle is like this, right? This angle is sum of interior opposite angle. Exterior angle of a triangle is equal to sum of interior opposite angle. If this is 58, this is 32, then this has to be 58 minus 32. How much is that? 26. This angle is how much? 26. Exterior angle of a triangle is equal to sum of interior opposite angles. So 58 should be equal to 26 plus 32. I'm using this big triangle TQP. Okay, what are the interior angles? 32 and 26. They sum up to 58. Okay. Now look at SP is creating 26. SP is also creating here. So this should be 26. Right? Chord SP is creating one angle at Q and it is also creating at this place 26. Now what is the sum of this? 58 plus 26. 84. With this we solve our task. This one RSQ is 84 and RQP is 64. Job done. So let me zoom out so that you can note. So then I'll move it to the center. See, we are going to write the answers now. PQR is 64 degrees and this is 84 degrees. Now we come to this question, and here what they are asking us to find. They have given a circle, they have given a tangent. Okay. Calculate the radius of tennis ball correct to the nearest millimeter. They have given in centimeter, we have to convert into millimeters. So 20 centimeters is how much? 20 into 10, 200 millimeters. Okay. So this is also a tangent, this is also 200. We don't even need that. Draw a line here. Draw a line here. This will be 15 degrees, half of this, because these two triangles are congruent, 15, 15. And this one is definitely 90, this is radius. Now, can we use trigonometry? 200 R, 90. This is also 15. So, which one? Opposite we have adjacent we have. We will use tan. We can write tan 15 equals to R upon 200, therefore R equals to 200 times tan 15. Do this, you will get the radius of the ball. .58, so we can make it 54. 53.58, because they are asking nearest mm, We'll round it off to 54 millimeters. Okay, that should be the radius of the ball. Easy, it was very simple. Move on to the next one. Okay. XY is 20. The whole thing is 20. And XZ is 22 from here to here. And YZ is 18. Okay, clear? And they have given the area also. Calculate the length of rope. Which rope? A dog is tethered to the rope attached to a post O. Okay, this OS is the rope. This is R. Okay, this is what we have to find, the length of the rope. And total area of this whole triangle is given as 169.7 meters square. How do you proceed? Which theorem you are going to use? Now area has come. Suddenly we were doing angles and lengths. Now suddenly area has come, right? So we will divide this whole thing into 3 triangles. Look very carefully, kids. See, I will use bright red color. This is also R, this is also R. See, look at the 3 triangles. OZ, OXZ. This is first triangle. This one is the first triangle. What is the area of this? Half base 22 into R. R is the height of this triangle. Correct? Now similarly, look at this another triangle, second triangle, which I will use this color, this triangle. So this is half of base into height, right? Plus half, base is how much? 18, and its height is this radius. Why I am calling them height? Because the radius always make perpendicular to the tangent. Okay, so 18 into R. Plus the third triangle is this, half of 20 into R, half of 20 times R. Now all 3 triangles together is the big triangle. Triangle 1, triangle 2, triangle 3 make big triangle. So this area of first triangle, second triangle and third triangle. All 3 triangles sum up to which one? 169.7. 169.7. Now what is the unknown variable? R, and you have all the numbers here. So I can make it very simple. Half R I am going to take common. 22 plus 18 plus 20 equals to 169.7. Right? Little bit of algebra. We have taken things common. R by 2 is common, right? Half R. So now our R will be equal to 169.7 times 2 divided by sum of all these things. 22 plus 18 is 40 and 60. Right? The sum of this is 60. So we have our answer with us, 169.7 times 2. This 2 goes to the numerator and divided by 60. 2.32. 2.32 meters. So the length of rope is 2.32 meters. You understood what we did? We divided the whole triangle in 3 triangles where we knew the base and the height was the radius. And 3 triangles, we added the area of all 3 triangles here, and the area of all 3 triangles was equal to the area of the larger triangle, and we got an equation and we solved our R. So pause and do it yourself. Done? So we will move to the next question. Here, OB is the center of circle, TB is tangent touching the circle. Okay, I agreed. This is here. Calculate OBT. OBT. Our task is to find this angle. Question, I'll use another color. OBT is a task. DA, okay, they are asking us DA. Radius, DA and AB. So all these things we can find if we are able to find this angle. Okay, this is 90 because tangent and diameter or radius are perpendicular. 90. If this is 90, this is 64. How much is this? 90 minus 64. Look at this triangle, TDA. TDA. So if this is 64, this has to be 26, right? Now we have this one, 26 is done. इसको कैसे find करें? So this is 26. Now this is isosceles triangle. This is also 26. Okay. Now if these two are 26, this will be how much? 52. Now 90 and 52, though this has to be 90 minus 52, which is 38. Done. 38 degrees. See, we are using always right angle triangle, angle sum properties. We had 90, 64, we found this 26. Now these two, in this triangle, OD and OC are radius isosceles triangle. So equal angles 26, 26. Now this exterior angle of this triangle, 26 plus 26 will become 52. Now when you have 90 and 52, you get this angle 38. So now they are asking us 80 equals to 9.2. 9.2. Calculate the radius of circle. First we will find the whole diameter because we have 64. So we will write diameter. I will use capital diameter. All I will write dt upon 9.2 equals to tan 64. Can I? dt upon 9.2. dt upon 9.2 is tan of 64. Okay. Therefore, dt equals to dt, which is our diameter. dt will be equal to 9.2 times tan 64. 18.86. 18.86. Now this is the diameter, we want radius, so divide by 2. 9.43. Calculate 9.43 centimeters. And dA. Now dA again can be found using cos. Cos 64 equals to 9.2 over dA. So dA will be equals to 9.2 over cos 64. 20.98. 20.98. So we are using both circle theorems as well as trigonometry, and this is how your IB questions will look like. Okay, so you have to practice a lot of questions like this. Go to our website, open circle theorems, go to type 5 questions where you have all the kind of questions which they ask in exam. Okay, and we have done most of them, but still you can practice the other questions, and if you still find difficulty, you can always refer the mark scheme. AB. How do you find AB? This is a part which is semi part of this triangle. So we know this radius. Radius is how much? 9.43. So using this, can we find complete TB? We can. So tan 38. I am using this triangle. Tan 38 equals to 9.43 over TB. If I find TB, I will subtract 9.2 from there. I will get AB, right? So TB equals to 9.43 divided by tan 38. 12.06. The whole thing from here to here is 12.06. So AB will be 12.06 minus 9.2. 2.86. 2.86. So we solve this question too. Okay. So this is 2.86. I hope you are understanding the way I am doing. Still, if you find problem, you can always write to me on the mail. And if you want if I want me to go slow or elaborate on few things, you can always write to me. You're free to write. Okay. So copy this. Pause the video. Copy this. Done. Okay. Now we will do the next one. In the diagram, AB and AC are the tangents. Okay. Great. So, and these are radius. So whole angle is, obviously we know it is, the whole angle is 90 degrees. It makes 90 degrees. Okay, we'll use different color. So what we know that these two angles are 90 degrees. Okay. And BAC, we have to find BAC. This angle is the task. And they have given AB is 24. So obviously AC will also be 24 because tangents from external point are equal. Okay. The radius of circle they want us to find, and the distance OA. Okay. Complete OA. How do we do this? Now don't confuse with the thing. Okay. Look at this. This is 102. So this angle will be 204 because the angle at the center is double the angle which it makes at the. So similarly, you can find this angle now. 360 minus 204. (156). Inside it is 156. Now draw a line straight from here to here. So 156 divided by 2. Each angle is 78, and this is also 78. Okay, easy to understand. Because this was 102, the angle at center will be double, 204. Because it is 204, the inside thing we got 156, and then I divided the shape in two parts, two equal congruent triangles, 78, 78. Now this is the radius. They ask radius, so radius is tan of 78. Tan of 78 is equal to 24 upon r, 24 upon the radius. So radius is 24 divided by tan 78. So how much it is? 5.1. Radius we get as 5.1. So we have solved the radius. 5.1. Distance OA, once again we can use sine of 78, isn't it? We will use sine of 78. We'll use this triangle, opposite over OA. We can write sine 78 equals to 24 over AO or OA. So OA will be equals to 24 divided by sine 78. Which is 24.53. 24.53. Understood? It was easy. So we used trigonometry and we also used circle theorems to solve this kind of questions. Now let's see what's next. Tangent circle O, BAC is 65. Okay, see this one. These two tangents are equal from external point. Okay, so if this is 65, this also has to be 65. 65, 65, 130. So this has to be 50 degrees because in a triangle the sum of all the angles is 180. So we already found Z is 50, 65y. Now this is 50. What I told you about this one, if you divide it into two parts like this. Hey, what happened? Divide it into two parts. So this is 25, this is also 25. Okay. Now 25, 65. How much will be this? 65 and 25, 80, 90. So how it is. So some problem. 65, 65. To 130. 65 and 25. 65, 25. So this question now, see, this is isosceles triangle because tangents to the circle are equal. So if this is 65, this has to be 65. 65, 65 is 130. So this has to be 50 because sum should be 180. 130 plus 50 is 180. Correct? Now if this is 180, this is 50. How much is y? The sum of these two triangles also I told you is 180. So y is 130. And if this is 130, x is how much? 65. Because half, whatever the arc is making at the center and what it makes at the segment will be half of it. Okay. So this is 65. So all angles done. X is 65, y is 130, and z is 50. Done. This was a relatively easy question. Okay. Can we proceed to the next one? Okay, we have come to end. So I request once again, go to examprep.world, practice questions from there, and once you are done from learn and practice zone, go to download worksheet zone, download the worksheet, which is the second window of our website. Practice the worksheets. I have downloaded the worksheets. It is in PDF form. Download and practice. And if you still get some doubts, you can always write to me. Thank you.